So we have a question on error in measurement when it comes to quotient and multiplication. Now the question is written in the description below, so if you want the question you can easily go to the description, click the description and you see the question, so you can easily know what we are solving. Now the question says that we have a mass m which is equal to 3.5 kg plus or minus 0.1 kg. It's also said we have a velocity v which is equal to 20 meters per second plus or minus 1 meter per second. And we have the radius r which is equal to 12.5 meters plus or minus 0.5 meters. Now how do we get this 0.1 kg, 1 meter per second, 0.5 meters? I've already said it in my previous video when I started the introduction into errors in measurement. So it's very easy to get. What it means is the difference in the calibration of the instrument used to measure the mass is in 0.1 kg. The difference in the calibration of the instrument used to measure the velocity is 1 meter per second, and that of the radius is 0.5 meters. In the calibration is in the calibration of 0.5 meters. That's the error. So it's possible the person wants to measure 12.5, but the person actually measured 12.6. So that is plus 0.5. It's possible the person wants to measure, person now measured 13 meters, that is plus 0.5. It's possible the person measured 11 meters, that is, or 12 meters, that is minus 0.5. So whatever it is going to be plus or minus this as the error in measuring this. So the question is that we should find the maximum possible error in the measurement of the force of an object. The force of an object is given as mv squared over r. Now how did I get the formula? It's very easy. I just looked at the parameters given to us, mv r, and since we are dealing with a rotational body, then we'll actually consider the centripetal force, which is mass as acceleration. Acceleration is going to become v squared over r. If you want to know how we get that, how we do that, check our playlist. You see videos on centripetal force, centripetal acceleration, and the rest of them. Be able to understand how we came up with this formula. But majorly, it is based on the parameters given to us that we derive this formula from and what we are looking for. Now, where m is the mass, v is the velocity, and r is the radius. So we have to look for the error in force of this particular question. So first of all, let us get the force in this particular question. So the force is going to give us the average value, as we've discussed in the other video when we discussed error in introduction to error in measurement. The force is going to become the average value. So the force is equal to our mass. Our mass is what? 3.5 kg. Our velocity is what? 20 squared. And our radius is what? 12.5 meters. So what is going to be our answer? 112 Newton. So that's our average value. That's our value of our force, 112 Newton. Remember, for us to get the error in this particular question, the error in the force, we use this formula that the error in the force divided by the normal force is equal to the first parameter there is the mass. The error in the mass divided by the mass plus next parameter there is the velocity. But we have it as 2 error in velocity. How do we get the 2? We already explained it in the beginning of this video, so you can easily go back to understand how we got that 2. Then we have the last one as the radius, the error in the radius over the radius. So this is the formula we are looking for. So if we know the mass already as that, we know the error in the mass as this, we know that of velocity as this, we know the error in the velocity as this, we know that of the radius as 12.5, and the error in the radius as 0.5. So we know now we've known that of the force as 112. What we are looking for is the error in the force. So we can easily put this into this formula to get the error in the force. So we have that the error in the force over our force is what now? 112 is equal to what's the error in the mass? 0.1 kg over what's our mass? 3.5 plus what's the error in the velocity? 1 meters per second. So we have it as 2 times 1 over what's our velocity? 20 plus what's the error in the radius? 0.5. What's our radius? 12.5. So we have that the error in the force over 112 is equal to what will be each of them. We have this as 0.0286 plus 2 over 20, that's 1 over 10. We have it as 0.1 plus 0.04. So we have error in force over 112 is equal to, we add all those together, what do we have? 0.1686. 0.1686. So at this point, since we are having a quotient at one side and an equality sign, automatically we know we have to cross multiply. If you don't know why we did that, you can check out our video on cross multiplication where we explained when to cross multiply and how to cross multiply. So cross multiply here, that means this numerator multiply this imaginary denominator here, we are left with what? Changing f. Why this 112 multiply that? So we have it as 112 times 0.1686. That will give us 18.88. 18.88. What's the unit of the force? Newton. Remember, our force is Newton. So this is our force now. Our force is now equal to F is equal to 112 Newton plus or minus 18.88 Newton. That's our calibration for the force. So the force is going to be 112 Newton plus or minus 18.8 Newton. Now, how do we know if this experiment is good to go through, or we need to redo the experiment? We have to calculate the percentage error in the force. So percentage error in the force is equal to the error in the force over our force times 100%. So what is the error in the force? 18.88. What is our force? 112 Newton times 100%. So what will be the answer? 16.86%. 16.86%. So we have our percentage error at 16.86%. Are we sure this particular experiment is good to go through, or we need to repeat it? Tell us in the comment section below if 16.86 is okay for us to go through with the experiment, or we need to repeat this particular measurement again for us to be able to know if these measurements are accurate. Tell us in the comment section below, so we'll be able to know we're actually following the video. So that is how to get error in measurement when you are dealing with quotient or multiplication. I've already told you in my previous video, when we are dealing with addition or subtraction, how you get the error in the particular experiment. So as a recap, error is required to be calculated in a particular experiment to know if the experiment is good to go through or to be repeated. And the error is above 30%, then it is going to be supposed to be repeated. But if it is below 30%, then we have to go through with that particular experiment. So thank you very much. If you don't subscribe to our channel, do so right now. Subscribe to our channel, click the notification button so when we post a new video, you'll be among the first set of people to get the notification. Also check our Facebook page, learning area, as well as our WhatsApp. Our WhatsApp contact is in the description section. And thank you very much, and do have a lovely day.